guys. Hi. We are on the 4th page of your notes. It says geometric sequences and series because we practiced the arithmetic so far. So the nice thing about now is that we know what everything stands for. We understand that we're just plugging into formulas. And so geometric is the exact same thing. You could be asked for different parts of the formula, but it's just plug in what you know and find what you don't. And at some point, I think I did talk about, well, we talked about how D stands for difference. The only thing is that the geometric formula has an R in it, right here. So this is the formula for the sequence, okay? And the R stands for ratio, okay? And that's right, in the definitions, that's where I talked about difference and ratio. So the ratio is what we're multiplying or dividing by, or the fraction, okay? So the ratio is multiply or divide or the fraction. Okay, because it could get tricky where it's like 2/3 or something like that. But if it's multiply, you know it's times 2 every time. Or if it's divide by 3, you could also see that as a fraction. So, so that's kind of what we're talking about here. Everything else we already know. So let's just go through, list what we have, and then we're going to find what we need. So I think this marker will show up well. Okay, so the formula, we need a n. We need the first term, and we need the ratio, and we need n, okay? So the 6th term, so that means n is 6. If the first term is 3 and the ratio is 5, so that means we're looking for what the value is. So the formula, A6 is what we're looking for. The first term times the ratio with a power of 6 minus 1, and that's what that means, is I put in the term and I take away 1, so that is just 3 times 5 to the 5th, and I'm going to use my calculator from here. 3 times 5 to the 5th is 9,375. Okay, so these numbers are going to probably be either much, much larger or much, much smaller than the arithmetic, because when you multiply or when you divide, the numbers grow or shrink much faster, okay? So one way you can know what kind of series or sequence you have is how quickly the numbers grow or don't. Or shrink, okay? So find the 5th term. So I know there's a glare right there, so let me move it over. So a to the n, a1, r, and n. Okay, so find the 5th term, so that means term is 5. Find that term is really what we're looking for. A is 1/2, and the ratio is also 1/2. Okay, so again, if you want to convert it to decimals, that's fine. But again, we've got fractions, but we still solve it the same way. So we're looking for the value of the 5th term. The first term is 1/2 times 1/2 to the 5 minus 1 power. And I did put parentheses around it just so that we're careful. If it were negative, you'd want to use parentheses just to be careful. So that's 1/2 times 1/2 to the 4th power. And again, because this is dividing, or because it's fractions, this is actually going to, and when I put my calculator, I'm going to go ahead and put parentheses around both. 1/2 to the 4th power. Math, enter. So I'm going to go ahead and make it a fraction. I did get a decimal out. 0.03125, but that is a fraction. It's really 2 to the 5th power, because you've got 2 to the 4th right there, and then 1 more. So again, either it gets really, really big, and this is only the 5th term. This is only going out 1st, 2nd, 3rd, 4th, 5th term, and it's already down to 1/32, or 0.03125. So that is just, again, the same idea, but a different formula. So let's look here. Find the number of terms. So when we're going through what we know, the number of terms is what we don't know. We don't know how many are in here. We know the beginning is 3, and we know that the end is 192. And we can also find the ratio. What are we multiplying each of those by to get to the next number? Well, it's times 2. 3 times 2 is 6. 6 times 2 is 12. So we know that the ratio is 2. So again, same formula, but we're just going to solve it a little bit different way. Now, when it comes to this solving, we're going to look at things kind of uniquely compared to what we've done before. 2 to the n minus 1 power. We're trying to find a power here. So I'm going to show you how we can look at that. So the way we want to do it first is we want to divide the 3 out. That way we've got 2 to the 2 with an n minus 1 power. 192 divided by 3 is 64. So really what I would ask myself is 64 is 2 to what power? Okay? So let's convert this. 2 to what power is the number 64? And if you, I know we had it like off to the side, but we know that 2 to the 5th is 32. I just talked about that right there. So if I multiply that one more time, that's 2 to the 6th. So since I know, let me put it right here, that 2 to the 6th is the same thing as the number 64. Okay, so I'm rewriting that 64 with a base of 2. That makes it easier because then I can compare. Well, if these are both 2, then that means this n minus 1 needs to also equal 6. So what you can do is you can actually erase those and just focus on that part. Just focus on the powers. So let's just focus on those. Those are equal. And if I add over, that means that n must be 7. Because 7 minus 1 is what would give you the 6th power. Okay? So, so you kind of have to think a little bit differently in the solving, but it's the same formula, it's the same approach. So let's do it one more time over here. A to the n, or excuse me, a sub n, a sub 1, the ratio, and the number of terms. Same question. So the last term is 320. The first term is 5. Number of terms is what we're looking for. So the ratio, what am I multiplying by each time? Be careful, it goes positive, negative, positive. So that means I'm multiplying by a negative 2, it looks like. Because that's going to change your signs back and forth. Whenever you see signs going back and forth, you know it's a negative number that you're multiplying by. So the ratio is negative, okay? All right, so let me plug it into the formula. 320 equals 5 times negative 2 to the n minus 1. Again, let's divide the 5 out. That way, I just have the number, the base, and its power. So 320 divided by 5, 64 again. Well, that's kind of helpful because we've already done 64. So 64 is negative 2 to the, what did we say, 6th power? Okay, and we do want to use parentheses. I wasn't sure if I wanted to throw them in, but we do because negative 2 to the 6th, all of those negatives will cancel out, and that's how we still get a positive 64. So that means that this is negative 2 to the n minus 1. Well, what does that have to be in order for it to turn into a 6? Well, again, you can just focus on the powers, and if you add 1 over, that means that n needs to be 7 again. Okay, it happens to be very similar. The setup was different, but then the powers ended up being the same, just because the ratio was very close, times 2 and times negative 2. So just remember, if you're looking for a power, turn this number into the same base so that you can just compare those exponents, okay? All right, so we are going to use the same formula and do a few more similar to it, and then we're going to talk about the series formula as well, okay?